Right, so welcome back. So in this video, we'll be looking at how to prove identities. To be specific, trigonometric identities. Here we have about 3 guidelines. The first is that if you have, you want to prove an identity, you start with, because an identity will always have 2 sides, the left-hand side and the right-hand side. So you start with one side. So you pick one side of your choice or which one you feel might be easier. For example, you could start with the left-hand side. And when you start with the left-hand side, the goal will be to transform the left-hand side to become the same as what you have on the right-hand side. So you can do that by using known identities. You can use any of the identities so far we've discussed. It could be the Pythagoras, it could be the reciprocal, it could be the even odd, it could be the co-function identity. And you just try to take the side you've chosen, and you try to use those identity to convert that side to be equal to the other side. So if you start with the left-hand side, your goal is to transform the left-hand side to look exactly like the right-hand side using known identities. And it's also advisable if you can convert to sines and cosine. So if you are confused, you don't know the identity to use, you can easily convert everything to sine and cosine, and you can proceed from there. So let's pick some few examples. For example, example 6, you have that we want to verify. To verify means you want to prove the identity. You are not simplifying. So you just take one side. So you have to look at both sides that you have. If we see this as our left-hand side, and you see this as our the right-hand side. So here, clearly, you see the left-hand side is only one term, and the right-hand side is 2 terms. So it will be easier if we take this one. So we will start with the right-hand side, which is 1 over minus 1 over 1 plus sine x. And then we will proceed just like we did in the earlier examples under simplification. So what is our LCD? Our LCD is just going to be 1 minus sine x and 1 plus sine x. So if we multiply by the LCD, so this will become 1 plus sine x over 1 plus sine x. And here we can multiply by 1 minus sine x over 1 minus sine x. So this is what we're doing here. So this is 1 over 1 minus sine x. And remember, there's a minus here, and this is times 1 over 1 plus sine x. So the purple one is just multiplying by the LCD, just to make it the fraction, the denominator, the same. Now, this will be 1 plus sine x, right, minus 1 minus sine x. Everything now will be 1 plus sine x multiplying by 1 minus sine x. Okay, well, let's go ahead to simplify. This will be 1 plus sine x. If you expand the bracket with the minus, you'll have minus 1 plus sine x. Now, this is difference of 2 squared. This is just 1 minus sine squared x, right? And then you will see that we can easily take away this 1 and 1. So we will just have 2 sine x over 1 minus also from the denominator, you can see that this becomes cos squared x, right? So we have to look at we cannot stop here. So we have to look at the right-hand side. What is the right-hand side? The right-hand, sorry, we took the right-hand side. The left-hand side is in terms of tan and sec. So we have to see how can we convert this to tan and sec. But if you look carefully, we can write this as 2 sine x over cosine x multiplied by 1 over cosine x, right? So this is the same thing as 2 sine x over cosine x will give us tan x, and 1 over cosine x will give us sec x. So this we're done. And you can see that this is exactly the same as the what? The left-hand side. So therefore, we know that our right-hand side is equals to our left-hand side. So this is indeed an identity. Right. Okay, so let's look at this one here. Now, if you look at the B, also you have the left-hand side and also the right-hand side. So which one is going to be more easier? Here we can try any one. You can use the left-hand side, you can use the right-hand side. But usually you will see that one side is usually more easier. So you can try the two, but in this example, let's just attempt the two, and let's see if, for example, if you take the left-hand side, what is the left-hand side? The left-hand side is cosine u over 1 minus sine u. So let's try to transform this to the right-hand side, and that we can achieve if we multiply this by 1. Yeah, we can multiply this 1 plus sine u. We can rationalize it over 1 plus sine u. So take note here, we are not multiplying by the LCD. We're just rationalizing because I'm using just the left-hand side. So this now will become cosine u multiplied by 1 plus sine u over what? The denominator is going to be 1 minus sine u multiplied by 1 plus sine u, right? So this will give us cosine u plus, is it cosine u now? Sine u, right? Okay. Now divide by this one, which will be 1 minus sine squared u, right? And this is going to be cosine u, okay, plus cosine u sine u over, the denominator is just cos squared u, right? Now, if you look at this, what is our goal? Our goal is to transform it to the right-hand side. So we have to be looking at what we want. We want to have sec u plus tan u. But here we can also take cosine u as a common factor so that you have what? 1 plus what? Plus sine u. Am I correct? Then now you are dividing by cosine squared u. So it means that we can cancel out. We can cancel one cosine. So this is cosine, can cancel one cosine. So here we'll just have 1 plus sine u over cosine u. Yes. Then we can separate this as 1 over cosine u plus sine u over what? Cosine u. Now, this is nothing but sec u plus what? Plus tan u. Right? So we're done. And, you know, this is the same thing as what? This is the same thing as tan u plus sec u, which is actually, okay, I think we can even stop here. And this is our what? Right-hand side. Yep. And we're done. Okay, now let's see. Let's assume we're just trying to see if we start with what? Let's assume we start with our right-hand side now in this case. If you start with right-hand side, you don't have to do both. One side is okay. If you start with the right-hand side, it means we will start with sec u plus what? Plus tan u. So the best thing will be for you to convert everything to sine and cosine. Since the left-hand side, everything is in cosine and sine. So this we can write as what? 1 over cosine of u plus this now can be written as what? Sine u over what? Over cosine of u, right? And what can we see from here? So we can see that now this is what? This is 1 plus sine u over what? Cosine of u. You see? Yeah, but if you look at this now, this is not exactly what we want. It doesn't look like what we want, so we cannot stop. Yeah. So it means that here we have to all be looking at your target. If you look at the target, which is the left-hand side, we have cosine u up, and then we have 1 minus sine u down. So what we can do is we can multiply this by the conjugates. Let's say 1 minus what? Sine u. 1 minus sine u, because we want 1 minus sine u downstairs. So now this we can expand this. So it means now we have 1 plus sine u, 1 minus what? Sine u over cosine u multiplied by 1 minus sine u. See? So this will just become 1 minus sine squared u over cosine u multiplied by 1 minus sine of u. And now this will be 1 minus sine squared u is what? Cosine squared u over cosine of u multiplied by 1 minus sine of u. And now you can see that we are getting close. Okay. So here now, we can reduce one cosine. One cosine will go with one cosine. So you have cosine of u over 1 minus sine of u. And you can see that this is the what? This is the left-hand side. But if you look at it, you would think, for me, I think taking the left-hand side and showing is equals to the right-hand side is easier than using the right-hand side. Because using the right-hand side, when we got here, you see, we had to what? We have to rationalize. But now with the conjugate of the numerator, and then, but it's okay. And either way, it's fine. So let's go to this one. Now, for C, so you have to just look, you have to take a look and see which side will be easier, then just go for it. Here, I think if this is your left, this is the left hand, right? And this is the right hand. So I'll take the left-hand side. I think it's easy, much easier. You have tan x plus cos x all squared. So this is just by expansion. If we expand this, this will just be what? Tan squared x plus what? 2 tan x cot x, right? Then plus cot squared x. And this is nothing but what? Remember, this is our goal. We want to reach this one. But here you can see this is tan squared x plus 2 tan x and cot x will cancel out because tan is what? Sine x over what? Cosine x multiplied by cot x is what? Is cosine x over sine x. Then you have cot squared x. So this will go with this will go with this. So we have tan squared x plus 2 then plus what? Cot squared x. Correct? Yeah. So getting to this point, you have two options. We can, yes, we can write this. Remember, we have to be looking at what you look at the target. What do you want? You want sec squared x and you want cot squared. Remember, we can get sec squared x from where? From tan square. And we can also get cosec squared x from where? Cot square. So we can split this as tan squared x plus 1. You know, this is 2. This 2, we can write it as 1 plus 1. So this is 1 plus 1 plus cot squared x. But what is tan squared x plus 1 will give us what? Will give us sec squared x. Then plus this one is equals to what? It's equals to cosec, right? And we're done. So this is what we have. And don't forget, this is our right-hand side. Okay. All right. Now you can also try to use the what? You can try to use the right-hand side to show it's equals to what? It's equals to the left-hand side. So you can try that. It's not that difficult in this case. All right. So let's see. But let's see. I think we can just do it quickly here. So let's say alternatively now. This is alternatively. Huh? So you don't have to do this one. You take the right-hand side. What is the right-hand side? Is sec squared x plus what? Sec squared x plus cosec squared x. But what is sec squared x? Sec squared x, we know, is the same thing as what? Tan squared x plus what? Plus 1. Then plus cos squared x is the same thing as what? Cot squared x plus what? Plus 1. So now you see now what you're doing is like you're trying to do reverse, but the reverse is sometimes it's tougher because this, you need to be able to see it, because what is the goal? The goal is for you to get back to, we want to get something like tan x plus what? Cot x, all what? All squared. Yeah, so here you can rewrite this as tan squared x plus 2, right? Then plus cot squared x. So you see it's the reverse. So from here, it's clear. You have squared here, you have squared. So the problem, what you need to think about now is the middle term. This middle term, how can you get, because if you want tan x plus what? Cot squared x, you need to have what? You need to have tan squared x plus what? 2 tan cotan, then plus cotan squared, right? But this, you can write this as tan squared x plus, now you have to create what you want, right? This is tan x cot x, which is nothing but just 1. You see? You see that this tan x cot x is just cosine x is just 1. So you have not really done anything crazy there. It's fine. It's just like multiplying 2 by 1. So now this will give us what we want. This was nothing but tan x plus cot x, all what? All square. And this is nothing but the left-hand side. And this is the left-hand side. All right, now let's see another interesting one here. Now, if you look at this one, you will see that what? For this, clearly, what do you need to do? You have to use the left-hand side because the right-hand side is only one term, right? So here we just stick with the left-hand side. So let me use the. So here we just need the properties of exponential function. If you look at this one, all these are the bases, E, E, E. And the first thing that is clear is that we can always combine, right? Because if you look at this, we can write these as what? E to power 1 and E to power what? 2 ln of what? Sine x, right? And this is E, so we can write this as E minus sine squared x plus what? Cos squared x. So this E we can take it at the base because this will become, if you expand, this will be E to power minus x minus sine squared x plus, and if you take this minus x, it will also go, this plus will become minus, so you will achieve this one. So these are just properties, right? Then you can see that. Now here also, but what is sine squared x plus cos squared x? We know it's equals to 1. So this is E to power 1. Then E, even this 2, I can take it up. So this becomes ln absolute value of sine x all squared. And this will become E to power minus 1. And this is E to power E ln of what? Sine x squared. E to power 1 minus 1 is something as 1 over E. So this 1 over E will go with this. So we'll have E ln of sine x all square. And here we can use the properties of logarithm. We know that this is nothing but what? Absolute value of sine x squared. And this is simply because if you have a to log to base a of what? Of x is just equals to x. We saw this in chapter 4, right? So now this also, we can just write this as what? As sine squared x. And this is why, because of what? Because of the absolute value. Remember, if you have x to power n is equals to what? X to power n. N is what? Is even. This is from one of the properties of what? Of absolute value. Okay. So, and this is nothing but what? This is our right-hand side. All right, so this is how to prove identities. And here, as you can see, here it is extremely, it's going to be extremely challenging for you to try to use the right-hand side to show the left-hand side because you have only one term. So it means you need to have to create a lot of things that are not natural. Yeah, it's possible, but it's going to be not natural because you have to be creating things. For example, you have to create this one, create exponentials and all of them. All right, thank you for watching. In the next video, we will be looking at how to use trigonometric substitution to simplify algebraic expression. Thank you for watching. If you are yet to subscribe to my channel, kindly do that and also like and share this with your friends.